Hello students, welcome back to the classroom point. In our today's class, we shall discuss one of the most important topic in chemistry, that is Eudiometry. So in this Eudiometry, we can solve the questions. Even without knowing the empirical formula, we can calculate the molecular formula of some compounds. Let us begin the class now. Eudiometry. So let us see the definition of eudiometry. Eudiometry is basically applicable to the gaseous components. Whenever the gaseous composition is given, by analyzing the gaseous composition, we'll come to know how much amount of the particular gaseous component is present in the given mixture. Or in the case of the organic compounds, we can easily calculate or identify the molecular formula of the compound. So let's begin one by one here. So eudiometry meaning is definition: analyzing the given composition of gaseous mixture with the help of a suitable absorbent is called eudiometry. So whenever some gaseous mixture is given, that gaseous mixture we have to analyze with the help of a suitable absorbents. Absorbents are another chemical substances which absorb the components of the gaseous mixture in a series of the manner. Let us see what are those here. So let us take the gas this side and absorbent. So if gas is either CO2 or SO2, these two gases are absorbed by aqueous solution of KOH or NaOH. If you take the oxygen gas, this is absorbed by pyrogalol. And if you take the ozone, this is absorbed by turpentine oil. And ammonia gas is absorbed by acidified copper sulfate solution. And NO gas is absorbed by FeSO4 solution. And CO gas is absorbed by ammonical Cu2Cl2 solution. And the last one is, if you take the chlorine gas, it has to be absorbed by water. So these are the gases, and whenever you take the nitrogen N2 gas, N2 is treated as inert gas. So N2 gas we should not consider. Even if it is present, we have to treat it as a inert gas. Now let us see how to analyze this gaseous mixture. Imagine we have taken the mixture of the gases. This is the mixture of gases. This mixture of gases, imagine, contains three gases, namely carbon monoxide, oxygen and NO. These three gases are present, and the total volume of this gaseous mixture I am taking it as a 100 ml. And we don't know what is the composition, means exactly volume of the each and every gas here, but together volume we know that is 100 ml. Now try to send this gaseous mixture through the aqueous KOH solution. So what is the nature of this aqueous KOH solution? Aqueous KOH or NaOH solutions can absorb either CO2 or SO2. So whatever CO2 is present in this entire gaseous mixture will be completely absorbed by the aqueous KOH solution, so that will get the remaining gaseous mixture. So this is the remaining gaseous mixture, remaining mixture of gases. So in this remaining mixture of gases, which gases could be present? O2 and NO. So O2 and NO are present. Now let us imagine the volume of this gaseous mixture is 60 ml. Then how much ml is reduced? 40 ml is reduced. Then that 40 ml was absorbed by which molecule? KOH. Which gas was absorbed? Carbon dioxide. So from this we will come to know that the volume of the carbon dioxide is equals to 40 ml. So volume of CO2 is equals to 40 ml. Now this gaseous mixture is having the two gases, O2 and NO, and together volume is 60 ml. Again, we don't know what is the volume of the each and every gas mixture, which gas component. So we don't know what is the volume of the each and every gas present in this particular mixture. Now let us try to send this gas mixture through the pyrogallol solution. So when you send this one through the pyrogallol solution, pyrogallol will absorb the oxygen completely and leaving NO gas out. So finally, the gas contains only NO, nitric oxide. So this nitric oxide volume is equals to 20 ml. So out of 60 ml, 20 ml is still present. That means 40 ml was absorbed by whom? Pyrogallol. Pyrogallol absorbs what type of the gases? Only O2. That means the absorbed volume completely belongs to the oxygen. So that here we will come to know that the volume of the oxygen is equals to 40 ml. So like this, by sending these gaseous mixtures through a series of the absorbents, we will come to know how much volume of a particular component is present in the given mixture of the gases. Apart from this, what other calculations we can do in the eudiometry? That is combustion analysis. Combustion analysis of hydrocarbons or organic compounds. So what is the meaning of the combustion? When a particular compound is burned in the presence of the excess amount of the oxygen or sufficient amount of the oxygen and converting every element into its respective oxide is called as the combustion process. All combustion reactions are exothermic in nature. Combustion is nothing but the burning. So you know that burning, you will feel the heat when a particular compound is burning. That means all combustion reactions are completely exothermic in nature. So now let us take the hydrocarbon. Hydrocarbon stands for the organic molecule that contains only carbon and hydrogen. Here, if you say organic compounds, means that may contain the heteroatoms also, like nitrogen, oxygen, chlorine, like this. But here we are going to calculate about the molecular formula of the hydrocarbons, which contains only carbon and hydrogen. Now let us see here. The formula of the hydrocarbon, I am taking it as a CXHY. Means X number of carbons and Y number of hydrogens are present. So these are going to react with oxygen. Here, as I said, every element has to be converted into its respective oxide form in the combustion reaction, so that carbon will convert into its respective oxide, that is carbon dioxide, and hydrogen will convert into its respective oxide, that is water. So that here X carbons will convert into the X moles of the carbon dioxide, and hydrogen will convert into the y moles of H2O. Now if you see the reaction is not balanced. Here carbons are balanced, X carbons, but hydrogens are not balanced because here Y hydrogens are there. Here 2 into Y, 2Y hydrogens are there. Then how to balance means, in this situation always use this number as the denominator, that get cancel out. So that here you write down the Y by 2. 2 cancel out, so that you will get the Y number of hydrogens. Now oxygens are not balanced. So how many number of the oxygens are present? Now see here, 2 into X, 2X, and here Y by 2, because one oxygen is present, 1 into Y by 2, so plus Y by 2 number of oxygen atoms are present. But here we are going to take the molecule. So whenever if you want to put the 2 here, then obviously here it has to be divided with the 2. 2 cancel out, so that you will get the 2x plus y by 2 number of the oxygens. Then if you multiply this term with this one, 2 cancel out, so that it will give the x, and 2 into 2 equals to 4, so y by 4 oxygen. So that here we can write down that the number of moles of oxygen available equals to, so required is equals to x plus y by 4 moles of oxygen is required. Then what could be the physical states of these reactants and products? In idiometric analysis, as I said earlier, it is used only to analyze the gaseous components. It should not be in the liquid state or in the solid state. So whenever they are in the gaseous state, then we can calculate the volume. So based on that, we can calculate the composition also. So here hydrocarbon must be in the gaseous state. We know that oxygen is in the gaseous state. Carbon dioxide is also in the gaseous state. Then what could be the state of the H2O molecule? If nothing is mentioned, means no physical state or no temperatures are mentioned, simply combustion process is mentioned, then we have to consider the H2O is present in the gaseous state. Apart from this, if any other categories like STP conditions or room temperatures or any cooling process, if these are mentioned, we know that H2O exists in the liquid state below 100 degrees centigrade. So on cooling means gases H2O will convert into its respective liquid form. Liquid form volume we don't consider it. So here we can write down that this side we can write down that at STP or room temperature and pressure conditions or on cooling, H2O is present in liquid state, so that we should not consider its volume when these conditions are mentioned. Otherwise we have to consider its volume also. Now let us analyze this reaction clearly and how it helps in solving the questions. So from this reaction, you must remember that in idiometric calculations we are using the volume combinations, not the number of moles. So here one mole means one volume, 2 moles means 2 volumes, 3 moles means 3 volumes. So here 1 mole of the hydrocarbon is present. So its volume I am considering it as a 1 volume. Volume could be in any of the parameters like milliliters or liters or meter cube. But all must be in the same terminology, that means same units. So 1 volume of the hydrocarbon needs X plus Y by 4 volumes of oxygen for its complete combustion, and will produce X volumes of carbon dioxide and Y by 2 volumes of the water. What if you take 2 volumes? 2 volumes of hydrocarbon needs 2 into X plus Y by 4 volumes of the oxygen, 2x volumes of carbon dioxide will be produced, so that Y volumes of H2 also shall be produced. Let us take 3 volumes. 3 volumes of hydrocarbon will require 3 into x plus y by 4 volumes of the oxygen and will produce 3x volumes of the carbon dioxide and need 3y by 2 volumes of the H2O in gaseous state. So then what happens if you take 10 ml? See that instead of the volume terminology, now I am taking the units directly. If you take 10 ml of the hydrocarbon, it needs 10 into x plus y by 4 ml of oxygen for its combustion and will produce 10x ml of carbon dioxide and also will give the 10y by 2 ml of the H2O. So this interconversions will help us in solving the idiometric calculations regarding the hydrocarbons and also help us in calculating the molecular formula of these hydrocarbons. Now let us see which type of the other formulas and other laws are helpful in the calculation of the idiometry. So the other rules that are very helpful for us are particularly Gay-Lussac's law of combining volumes. And also Avogadros law. So based on these two also we are going to calculate these idiometric calculations. So let us see what are those Gay-Lussac's law of combining volumes or Avogadros law that we already discussed in our previous classes. Once again we'll have this small discussion about this. So Gay-Lussac's law of combining volumes says that, let us take an example. H2 reacts with half moles of the oxygen and producing H2O in gaseous state. All are in the gaseous state. So Gay-Lussac's law of combining volumes, that is what we applied here, says that one volume of H2 always reacts with the half volume of the oxygen and produce one volume of the H2O in gaseous state. And if you take 2 volumes of H2, then here you need the 1 volume of the oxygen and shall produce 2 volumes of the H2O in the gaseous state. That is what Gay-Lussac's law says that. Then Avogadros' law says that at STP conditions or at any given conditions, pressure and temperature, equal volumes of all the gases contains equal number of moles. So number of moles directly proportional to the volume. That means when number of moles increase, volume also increase. When volume increase, they need the more number of molecules to occupy that. So that is the reason why in the same concept here we are doing that. We removed the volume means moles but using the volumes concept. Now by explaining this concept, we will have the clear some idea how this idiometry is going to use. But by solving the questions, you will come to know how actually we are going to use these formulas in getting the answers. Let's see that. Let us solve these questions now. The given question is 10 ml of gaseous hydrocarbon is exploded with 100 ml of the oxygen. The residual gas on cooling is found to measure 95 ml. So the residual gas completely cooled, so that finally there is no water in the gas state, only remaining gas are present, that is 95 ml, of which 20 ml is absorbed by the caustic soda. The remaining gas by the pyroglycol, the formula of the hydrocarbon is. So let us solve this question. Write down the Cx Hy plus X plus Y by 4 oxygen gives X moles of CO2 plus Y by 2 moles of the H2O. As they said that it is on cooling, H2O is in the liquid state and its volume we don't consider it. So these are all in the gaseous state now. They have taken 10 ml of the gaseous hydrocarbon. So it requires 10 into X plus Y by 4 moles of the oxygen is required. ml of oxygen is required and it will produce 10x ml of the carbon dioxide. So let's write down the given data here. Volume of the hydrocarbon CXHY is given as 10 ml. Volume of the oxygen given as 100 ml. This is given. Residual gas contains 95 ml. So after complete combustion, hydrocarbon converted into the carbon dioxide and the H2O, and there shall be some amount of the oxygen. So final gaseous mixture contains oxygen, carbon dioxide and H2O in the gaseous state. But they said they cooled the composition, so that H2O volume we don't consider it. So final gaseous mixture contains only oxygen and carbon dioxide, that is 95 ml. And this gaseous mixture they passed over the caustic soda, of which 20 ml out of the 95 ml was absorbed with the caustic soda. Caustic soda absorbs only carbon dioxide, so the volume of the carbon dioxide here is equals to 20 ml. So volume of the carbon dioxide is equals to 20 ml. Then how much oxygen? See, this paragraph or this sentence says that oxygen required. So volume of the oxygen required is equals to initial volume we have taken the 100 ml minus out of 95 ml 20 ml was absorbed, so remaining only 75 ml of oxygen is still present in the final gaseous mixture. So that 100 minus 75 ml, that gives 25 ml of the oxygen was used. Now let us solve here. See, regarding the carbon dioxide required 10x ml of carbon dioxide will be produced, but here how much is produced? 20 ml of the carbon dioxide is produced. 20 ml of carbon dioxide. So milliliters of carbon dioxide cancel out. 10x equals to 20, x equals to 2. Next, volume of oxygen required is 10 into x plus y by 4 ml of O2 is required, but it used only 25 ml of the oxygen, so that 25 ml of O2 was used. So milliliters and oxygen cancel out. So this equals to 10 into x plus y by 4 equals to 25. 10 if you send it becomes 2.5. X value is 2. So 2 plus y by 4 equals to 2.5. Y by 4 equals to 0.5. Y equals to 2. So the molecular formula of hydrocarbon, 2 carbon, CX means C2, HY means Y equals to, so that its formula is equals to C2H2. Now let us see the another question. Here 10 ml of gaseous hydrocarbon was completely burned in 80 ml of the oxygen at STP. So STP, whenever you say that, automatically H2O exists in the liquid state. The volume of the remaining gases is 70 ml. Volume became 50 ml on treatment with the NaOH. The formula of the hydrocarbon is, let's write down the formula again. CXHY in gaseous state plus X plus Y by 4 O2 in gaseous state gives X moles of carbon dioxide in gaseous state, Y by 2 moles of the H2O, but in the liquid state, because final volumes are measured at the STP conditions. So from this, what data they had given. 10 ml of hydrocarbon was used. So it requires 10 into x plus y by 4 moles of the oxygen is required and will produce 10x milliliters of carbon dioxide. So now let us write down the data here. Volume of the hydrocarbon CXHY is equals to 10 ml and bond in 80 ml of the oxygen. So volume of the O2 taken is equals to 80 ml. So at STP means volume of the H2O not considered, not necessary to consider. The volume of the remaining gases mixture contains only oxygen and carbon dioxide, that is 70 ml. And volume suddenly becomes now 50 ml after passing through the NaOH. That means how much volume was absorbed? Only 20 ml of the gas was absorbed. That could be the carbon dioxide by NaOH. So volume of the carbon dioxide is equals to 20 ml. Remaining volume of the oxygen is equals to 50 because that is what absorbed the pyroglycol. So only 50 ml of the oxygen is there, but we have taken the 80 ml of the oxygen. Here we need only the volume of the oxygen consumed in the reaction. So volume of the oxygen used in the reaction or reacted is equals to 80 minus 50 ml. So that equals to only 30 ml of oxygen was used. Now let us solve this question. 10x volume, 10x ml of CO2 has to be produced, but here it produced 20 ml of CO2. So that these are all cancel out. 10x equals 20, x equals to 2. Now let us see here. Oxygen 10 into x plus y by 4 ml of O2 is required, but here it used only 30 ml of O2. So ml of O2 cancel out. This goes 3 times. X value already 2 is there. 2 plus y by 4 is equals to 3. Y by 4 equals to 3 minus 2, that value equals to 1. So y equals to 4. So final formula of the hydrocarbon here is 2 carbons, 4 hydrogens. So that C2H4 is the formula of the hydrocarbon. So you can copy this one and we shall solve some more questions. So let us see again some more questions. The question is 7.5 ml of gaseous hydrocarbon was exploded with 36 ml of O2, which on cooling, means final mixture on cooling, the volume of the gaseous mixture was found to be 28.5 ml. So that H2 again in the liquid state, not necessary to consider. And 15 ml of which was absorbed by the QOH. So this is equals to volume of the carbon dioxide and rest by the pyroglycol. So let us see the formula again. CXHY in gaseous state plus X plus Y by 4 oxygen in gaseous state gives X moles of CO2 in gaseous state plus Y by 2 moles of H2O now in the liquid state. Why? Because it is considered already in the cooling. That's why we are not considering it. So here 7.5 ml of the hydrocarbon needs 7.5 into X plus Y by 4 ml of O2 and will produce 7.5x ml of CO2 and H2O volume not necessary to consider. So now we'll write down the data. Volume of the hydrocarbon is equals to 7.5 ml. Volume of the O2 that is given is equals to 36 ml. And volume of the carbon dioxide 15 ml. Final gaseous mixture is 28.5 ml that contains both oxygen and carbon dioxide, of which 15 ml is carbon dioxide. So remaining 13.5 ml is oxygen that is still present in the gaseous mixture. But we have taken the 36 ml of the oxygen so that we can write down that volume of the oxygen used or reacted is equals to 36 minus 13.5. This is equals to 22.5 ml of oxygen was used in the reaction. So now let us solve this question. Carbon dioxide 7.5x ml of CO2 is equals to produced 15 ml. 15 ml of CO2. Again these are cancelled. It goes 2 times, x equals to 2. Now let us see the oxygen. Oxygen is 7.5 x plus y by 4 ml of O2 equals to 22.5 ml of O2. ml of O2 cancel out. It goes 3 times. X value is 2. 2 plus y by 4 equals to 3, y by 4 equals to 1, y equals to 4. So that the formula of the final molecule, that means hydrocarbon, is C2H4. Let us see the another question here given. 20 ml of gas hydrocarbon requires 100 ml of the oxygen for complete combustion. They said complete combustion, so that again you not necessary to calculate volume of the oxygen used, because earlier in all other cases they had given the excess amount of the oxygen, so that excess amount of the oxygen and amount of the oxygen still present in the gaseous mixture. By subtracting this, we used to get the volume of the oxygen actually used in the reaction, but here only directly the value is given that we can take it. And 60 ml of the carbon dioxide is produced. So that here directly we can solve the question as volume of hydrocarbon CXHY is equals to 20 ml. Volume of the oxygen is equals to 100 ml. And volume of the CO2 is equals to 60 ml. So let us see the question. Here they did not mention anything about whether it is cooling or not, but here they had given one information that in this reaction 60 ml of carbon dioxide is produced, and regarding the 100 ml of the oxygen, so here we need to add the reaction is happening at STP. Hydrocarbon requires 100 ml of the oxygen for complete combustion at STP. So that not necessary to consider the volume of the H2O. Then now carbon dioxide 60 ml, hydrocarbon 20 ml, so that 20x ml of CO2 is equals to 60 ml of CO2. ml of CO2 cancel out, it goes 3 times, so x value is equals to 3. And volume of the oxygen, so here we can write down that 20 into x plus y by 4 ml of O2 is equals to 100 ml of O2. ml of O2 cancel out, 20 goes 5 times here, x value equals to 3, so 3 plus y by 4 equals to 5, y by 4 equals to 2, and y equals to 8. So the molecular formula of the hydrocarbon is C3H8. So these 4 questions are of only one type of the category. So for practice purpose, it helps you a lot. And whenever you see the question without first 2 questions, you can watch it. But afterwards, you pause the video and note down the question and try yourself. If you get it, it's okay. Or else you can see the answer later. Now let us see the other type of the questions where hydrocarbons are not present but gaseous mixtures are present. But one question still contains the hydrocarbon, but it is a different two categories of hydrocarbons are present. They are different questions. Now let's begin them. Now let us see one more question here. So these questions are very important for us. A gaseous mixture of propane and butane of volume 3 liters on complete combustion produce 11 liters of CO2 at STP. Find the ratio of volumes of butane to the propane at the same temperature and pressure. So let us see here solution. So as we don't know the volumes of the both propane and butane independently, so let us consider that volume of propane C3H8 is equals to X liters, whereas volume of butane C4H10 I am considering it as a Y liters. It is equals to 3 minus X, also will get the Y liters here. So now let us see the complete combustion reactions of both of these. C3H8 gaseous state reacts with oxygen, produces 3 moles of carbon dioxide plus 4 moles of H2O, but at STP, so that liquid. Now we need to balance the oxygen. Here 6 plus 4, 10 oxygen, so that 5 moles of oxygen in gaseous state. And similarly, let us write down the balanced equation for the butane combustion reaction also. C4H10 in gaseous state reacts with oxygen, gives 4 moles of carbon dioxide and 5 moles of H2O, which is liquid state whose volume we don't consider it now. So 4 into 2, 8, 8 plus 5 equals to 13. So 13 by 2 moles of oxygen was involved. Let's write down the reactions now here. Let us imagine X liters of propane participate in the reaction, which needs 5x liters of oxygen, could produce 3x liters of carbon dioxide. And here butane Y liters. So Y liters of butane reacts and produce 13Y by 2 liters of requires 13Y by 2 liters of oxygen and will produce 4Y liters of the carbon dioxide. So now let us see here, we know that X plus Y, propane and butane volume together equals to 3 liters. So X equals to 3 minus Y liters. Equation 1. It produced how much of the carbon dioxide? 11 liters of the carbon dioxide. So 3x plus 4y liters of carbon dioxide is equals to 11 liters. So volume of the carbon dioxide is equals to here 3x plus 4y is equals to 11 liters. Equation number 2. Now substitute the value of X in equation 2. What is the value of X here? 3 minus Y. So in the place of X we can write down the 3 minus Y. So 3 into 3 minus Y plus 4Y is equals to 11. 3 into 3 equals to 9 minus 3y plus 4y is equals to 11. Minus 3y plus 4y means y. So y plus 9. 9 you send that side, we'll get the 11 minus 9, that equals to 2. So value of y equals to 2. Then substitute this y value here, we'll get the value of x equals to 1. So what is the value of x here? X nothing but the propane volume. So this value is equals to 1 liter, whereas butane value equals to 2 liters. They asked the ratio of the volume of butane to the propane. So volume ratio of the butane C4H10 to the volume ratio of the propane H8 equals to, that is 2 by 1. That means we can take the 2:1. Let us see the another question here. 20 ml of a mixture of C2H2 acetylene and carbon monoxide was exploded with 30 ml of oxygen at STP. Again STP is mentioned. So that H2O could be in the liquid state. The gases after the reaction had the volume of 34 ml. On treatment with KOH, 8 ml of O2 is still present. Calculate the composition of the mixture. So let's write down the balanced equation for all these. C2H2. C2H2 in gaseous state reacts with the oxygen in gaseous state, produce 2 moles of CO2 plus 1 mole of H2O in liquid state. So 4 plus 1, 5. So that here 5 by 2 O2. Let us take the carbon monoxide also. Carbon monoxide in gaseous state reacts with oxygen in gaseous state, produces CO2 in gaseous state. So here 2 oxygens, here totally 3 oxygens are there. So make it half. Cancel out, totally it is equals to 2 oxygens. So let's write down the given values here. Similarly, let us take again the volume of the C2H2 as we don't know. I am taking it as x liters. Reacts with 5x by 2 liters of oxygen will produce 2x liters of the carbon dioxide. And in the case of the carbon monoxide, let us take it as y liters, which reacts with y by 2 liters of the oxygen and produce y liters of the carbon dioxide. Now let us see here, x plus y value is equals to 20 ml. So here they had given everything in the milliliters. So we also change these units in the milliliters only. Milliliters and milliliters. So here also this is 20 ml. So x equals to 20 minus y. Equation 1. Here 30 ml of oxygen was used. Finally 8 ml of oxygen is still present. So volume of the oxygen consumed is just 22 ml. So that here volume of O2 consumed is equals to 22 ml. See, volume of O2 consumed means this value plus this value. So here 5x by 2 plus y by 2 equals to 22. 5x plus y equals to 44. Treatment with KOH 35 ml. So that, okay, no issue now. So here this is the equation number 2. Substitute x value here. Substitute the value of x in equation 2. So that we get, see here 5x value 5 into 20 minus y. So 5 into 20 minus y plus y is equals to 44. This is equals to 100 minus 5y plus y equals to 44. 100 minus 4y is equals to 44. So that here 4y minus 4y is equals to 44 minus 100. This is equals to 56. So minus 4y is equals to minus 56. So minus minus cancel out. So it goes 14 times. So y equals to 14. That means y value is equals to 14 ml. So that x value is equals to 6 ml. So x value is how much, which one that is? X is equals to acetylene gas. So its volume is equals to 6 ml. And CO volume is equals to YML. That means it is equals to 14 ml. So note down this one and we shall solve one more question. Let's solve one more question here. The given question is 20 ml of CO and H2 are mixed with the excess of O2 and exploded and also cooled. So there was a contraction volume of the 18 ml. Determine volume ratio of the CO and H2 in the original gaseous mixture. So let's do that. First of all, write down the equations for the combustion reactions, because they said explode. Explode means automatically combustion reaction might have taken place. So that CO and H2. So CO in gaseous state reacts with oxygen in gaseous state, gives CO2 in gaseous state, half O2. H2 in gaseous state reacts with again half volume of the oxygen to its volume, gives H2O in the liquid state, because it was mentioned at the STP conditions. So now let us see here. As we don't know the individual volumes of the carbon monoxide and H2, let us consider X liters of the carbon monoxide reacts with mLs are mentioned, so that let us take the ml, X by 2 ml of oxygen and producing the X ml of CO2. Similarly here H2, Y ml of H2 reacts with the Y by 2 ml of oxygen, and the volume of the H2O in liquid state has to be neglected. So now X plus Y value is given as 20 ml, both volume. So that X plus Y is equals to 20. So that X equals to 20 minus Y. This is the equation number 1. And they said here, there was a contraction in volume. Contraction in volume means volume of the reactants minus volume of the products. So if there is any contraction, that value will get it the contraction volume. So contraction volume or decrease in the volume can be calculated just by subtracting the volume of the products, total volume of the products from the total volume of the reactants. So now let us see here. Volume that is in contraction is equals to volume of reactants, total volume of the reactants minus total volume of the products. So how much volume was reduced? Just it is 18 ml. So let us take 18 ml is equals to volume of the reactants means CO, O2, H2 and O2. All these volumes here we have to write down. What is the volume of CO? X plus O2 X by 2 plus this is Y plus Y by 2 minus volume of the products. Only one product, that is negligible here. So that is X here. So minus X plus X cancel out. So 18 is equals to, so X by 2 plus 2 into Y, 2Y plus Y equals to 3Y by 2. So from this we can write down that X plus 3Y by 2 is equals to 18. X plus 3Y is equals to 36. Equation number 2. Now substitute the value of X from the equation 1 in the equation 2. So we'll write down that. Substitute the value of X in equation 2. So that we get here. X value is how much given? 20 minus Y. So this is equals to 20 minus Y plus 3Y is equals to 36. This is equals to 2Y, 20 minus 2Y equals to 20 plus 2Y equals to 36. 2Y is equals to 16. Y equals to 8. If Y equals to 8, then X could be equals to 12. So substitute this Y value in this equation. So X equals to 20 minus 8 is equals to 12 ml. So what they are asking here? volume ratio of CO. CO is X value. X value is 12. So volume ratio of this CO divided by volume ratio of H2 equals to 12 divided by 8. So 4 3s are 4 2s are. So that this is equals to 3:2. So dear students, I hope you understand the calculations and the concept of the idiometry. Idiometry can be understood not only by theory part, only by solving the questions. If you feel that this video is helpful to you, please do share with your friends and like the video, and do not forget to subscribe the channel and send your doubts to the classroom.point@gmail.com. Thank you one and all.